Is my voice audible? Yeah, it is audible. So, good evening, everybody. Yeah, we will be coding the AVL trees now. So, today is 6th of October, right? 6/10/2025. Let us try to code. So, first, let us write the algorithm for this one. First, we will be defining a node. Then, we will write the helper functions, right? Max and height. Then we will create, then get balance function, then insert function, then the main function for insertion, and I still need to learn division for AVL trees. So we will learn that later. So I should include yesterday and I should include yesterday. Record చేసుకోండి అమ్మా. So stdlib.h, and we will be writing the structure type def for writing the alias struct node in data. So, or you can write this node def no, since we are inside the struct node, like struct node right, and in height, right. This should work, I think, and you can call this one node or node, yeah. So the node data type is okay, and int height, right. Does it take any parameters? Yeah, I take the node parameter, node n, and it will return the, wait, yeah, it will return the, I mean, it will check the condition first. If n is equals to null, it will return 0, else it will return n of height, right? And then we will write the, after the height function, what will we write max? It will take two parameters in here and it b, like return if a is greater than b, it will return a, whereas b is a max function. And then we need to write a create function. The create function will take a value, right? So node, new node is equals to um, is a node data type. This is just the syntax for MLOp. Node MLOp size of node. So one node of data is equals to value. One node of left is equals to none. One node of right is equals to null. And the node of height, we will return it as 1. That is just the creation of node, and you will return new node to the function. And after this, what will you write? You will write the, that's it, right? You will write the get balance function, if I'm not wrong. Yeah. Int get balance, it will get the balance of node, right? So to return um, max of height of, no, it is not max. It will it will return height of n of left minus height of n of right. Right, it will return that. Mm. And then you can create the insert function. So for this insert function, it will take two parameters, the node to be inserted and the value to be inserted. So this is the insert function. Yeah, first we are going to write the base case. If n wait, n is equals to null, that means there is no node to be created. Right, if there is no node, you will just create value, create the function with value, and then what else could be the case? Yeah. So if you need to compare just like the normal binary search tree, if value is less than enough data, right? If the value is less than enough data, you will go to the left. Enough left is equals to you are calling the recursive function. Insert enough left comma value. You are going to insert the value in the left side. Else if value is greater than enough data, then enough right is equals to, you will insert it in the right side. That's it. Enough right and value. Right. Really don't know if this thing will work or not, but we are just trying. And else return not, because if duplicate values are not allowed. And this is just the normal BST insertion. Okay, yeah, that's what I have been thinking. All right, before the insert function, right, where, yeah, and create, and also write the left rotate and right rotate functions. And so left and right rotate functions, absolutely. Yeah. Now I was thinking like we came to the insert function and the code is still short, right? So node left rotate. So what parameter is it going to take? You are going to left rotate a node. So let's assume that node will be y. Okay, first the convenience is you are right rotating, right? Yeah, you will take y. I think so. So you will right rotate a node that is left dominant. So there will be x and x. Okay. I think I need to. I think I need to get my OneNote here. Something so that this thing will stick around. Just a second, people. Meanwhile, let's see if we got any chat from you people. Yeah. Yeah, as expected. Meanwhile, let's see if we got any chat from you people. All right. Let me just type the welcome message. Hello everyone, welcome to stream. So let's see if this thing is working. All right. For the left rotate, for the right rotate, you gotta be left dominant. So there is this X node, and it is Y, and this is T2. It is something like that. And this is something like T1, right? Subtree 1. Or you are taking Y here as a parameter, right? You will take the parent one, Y, X, T1, T2. Let's say it is something like that. And first you will replace the T2, you will write T2 is equals to Y, right? Then it will be like T1 and Y. Yeah. Yeah, it is like this, right? You are supposed to do it like this. That's it. This is not the one. So then you will write Y of left is equals to T2. And you will write an X. That's it. And similarly for the left rotate, what will you do is you will take the right rotated one, right? Y, X, and this is T2 and this is T1. Just improve our spatial coordination. So you will replace T2 with the Y. So it will be X, it will be Y, it will be T1, and then you will do something like this. So this is the opening one, and you are giving the this. You will return X here again as well. That's it. It's as simple as that. And then we are supposed to write these functions. Ouch. So right rotate, it will take Y, and now we are creating X, node X, node T2. Right, so first it is like this, right? Yeah. So Y of left is equals to X, and X of right is equals to T2. So you have now defined them. You can actually no, it's the opposite actually. Struct node X is equals to Y of left, and struct node T2 is equals to X of right. You have written this, and now you need to perform the rotation. Okay, after performing the rotation, you need to update the height of the new parent. Yes, right. You are going to update the height, right? Yeah, you are going to update the height because the parent node came down a bit, right? So yeah, now what you are supposed to do? You are supposed to perform the rotation. You will put T2 in the T2's place. It is like this, and the T2's place you will put Y. So T2 is actually X of right. X of right is equals to Y, and Y of left is equals to T2. That's it. Yep. It is yeah, X of okay. This is Y here. This is Y here. This is X here T2, and X of right is equals to Y, and now this is new Y. Y of left is equals to T2. That makes sense. And now you will update the height. right? Height, right? Come on. X y of height is equals to 1 plus max of height of x of left, comma height of x of right. Will you do that? Yeah, let's see. I mean, this is level 1, this is level 2, this is level 3. Now what happened here? This one became empty. Yeah, see, all right. This is okay. I mean, for this you did that. Okay, this is 1, this is 2, this is 3, and now okay, you are calculating the depth. Sorry, this is 1, this is 2, this is 3. Now this one became 1, this one became 2, this one became 3. So the x height was before 2, now it became 3, and the y height is before 2. Okay, let it be meant of height of. Okay, see, you are doing y here and x here. That is, it won't cause any compile time issues, it will cause runtime issues. That's the problem. Height of x of right, comma height of x of left. Just alter the order, shouldn't matter. That's it, and you took y and you will return x. That's it. And similarly, you will write the left rotate. Now you will take the node x, move the y is equals to, now it will be x of right, and now the node t2 will be y of left. So now y of left is equals to what? Yeah, y of left is equals to x. X of right is equals to t2. Just reverse what was there. Can you copy this? Now you will return y. That's it. I think this one should work. If not, we will just know. Now what? Now what? All right. You will just perform the rotations and you will return the node. That's it, right? Or is there anything else? Okay, you are supposed to get the balance factor. Yep. Okay, after insertion, you are supposed to update the height and of height, because the height is not going to get updated by itself. And of height is equal to 1 plus max of um, height of n of left, height of n of right. This is how we update the height, just like we have written over there. And now we get the balance, and balance is equals to get balance of right. You will get balance of n. Now you write the cases again. If balance is greater than 1, that means it is left heavy. Balance is greater than 1, and Okay, if okay, okay. Value is greater than enough data. If balance is greater than 1, that means left subtree minus right subtree is giving a positive value. That means it is left heavy. Let's say value is less than enough data. Right, that means it is LL rotation. LL rotation. Return left rotate and this code is totally making sense. Else if balance is greater than 1 and value is greater than enough data, that means we are in the left heavy, but it is a LR rotation. So first you need to do the LR rotation. LR. So first you need to left rotate. And after left is equals to left rotate. And after left, comma, value. You did the L and you will do the R now. Return right rotate. You will right rotate what? We will right rotate. Okay, this is where I get confused. So now, maybe this is where I'm getting confused because I didn't understand the concept clearly. And now left is yeah, let's this code correct. I am and then find it out writing. Done. Check it. You are very close. Okay, there are several small and important. Oh yeah. See that's what I was thinking. If you it didn't give me proper syntax type def. Very good. At return node. Yeah, that's not node. I mean, okay. I have taken yeah, absolutely. Okay, left rotate. Okay, you are just rotating enough left. It doesn't take two parameters. Absolutely. These are some beginner mistakes. Right? Semicolons. Return, right, rotate, and rotation conditions are mixed up. Balance is greater than 1 and value. Return, right, rotate. Right. Is that correct? Value is less than enough data. Okay. Enough, no, enough left of data. Why? Balance is greater than 1. Why writing left of data on right of data instead of data wanted get request to left of data on right of data. Okay. And then else if balance is less than -1, that means it is right side and value is greater than n of right of data. It is an RR case. Then we will return left rotate n absolutely. Yeah, from what I have understood, you just need a lot of practice. Else if balance is less than -1 and value is less than n of right of data. If it is less, that means this is an RL case. N of right is equals to right rotate and of right. Yep. And then you will return the RL right where rotate will left rotate and you will return it. That's it. And after all of this, you will return the and I mean the updated head. This is just the insert function. And you will write the void main. So the void main will take int array of let's say 6. Size is equals to 110, 357, 90. And actually to display the contents, you need to write an in order traversal. So void in order, it will take n as a parameter. And the recursive function, and if n is not equals to null, it will in order the n of left. And now what are you doing? Printf %d\t n of data. After doing the left, you will print the nodes data and you will in order the n of right. So if our code is correct, it should give us the ascending order values. So 1, 3, 7, 10, 50, 90 should be the answer. And in I, for I is equals to 0, I less than 6, I plus plus. I'm doing this because I don't need to write the insert function 6 times and node. Right. Okay, first you need to set up the node to null. Node n is equals to null. Why? Because the in order traversal should work until the node is null. And the create function's base case will also, I mean, the insert function's base case will also work only if the node is null in the initially. So this is an important step which I miss most of the times. So n is equals to insert. You are inserting That's it, right? We will insert n and array of I in order n. I don't know if this doesn't work. What will this is what 0, 6, 10, 20, 25. Very good. And very good as well. Oh my god. And actually wrote it. And then this okay, did I write left rotate? Yeah, I mean if balance is greater than one, that means it is left heavy, so you're supposed to give right rotate. So I don't know why the code worked. Okay, the code worked because I started off with this model value, I think. Yeah. Wow, now everything is making sense. Let's say I made this a mistake and let's say I started with 100. Let's see how this thing works now. Okay. See? See? Wow. Seriously? Sure, I'm doing it. The smallest value. That's the first one, so that's why the code works. Wow, this is not going. Right, clear. Right, I'm sharing. Wow. Maybe I'm a down, I'm a tester now. Right. Absolutely. We just right rotate. Wow, this thing should work. Yes, this thing worked. Yeah, no one's there in the chat yet. I don't know, I coded in like 20 minutes, we still have 40 minutes left, and we will end deletion. Right, let's ask ChatGPT what is the fastest way to learn code. What is the fastest way to learn code? And I'm dedicating 1 hour for this every day. Perfect. Don't just read code, write break. Ouch. We write active practice is 90% retention. That's correct. 10 to 40 minutes, 40 to 50. Reflecting. Now let's write a duration. I will describe the code in my common notes. Then try to code it without saying that's what's great. Explain, implement, debug, and refine. Ouch. Understand, explain, implement, debug, refine. Okay, normal BST deletion. If key is less than node, go to left. If key is greater than node, go to right. If key is node, if node has no child, replace it with that child or null. Node has two children. Find the in order successor. Minimum node in the subtree. Copy successor value to the current node. Delete the successor recursively. After deletion, update the height. Update each node side, backtrack and update each node side. Oh, we are even backtracking. Check balance factor. Balance is greater than 1 or less than -1. Tree becomes unbalanced. No rotation is needed. Apply the 4 rotation cases. Okay. Yeah. Give me the code and then I will write it in my whoops. Right. Oh, this is the entire code. Create, right rotate, left rotate, get balance. Okay, so you are writing the min value node. All right. So to find the in order successor, you will go to the left subtree until you hit the null value. That is what you are doing. So in the insert function, I have written this and delete node. If root is null, return root. That is the base case. Write the base case first. Let's put this thing. Let's get our cursor and let's just write some things. Oh my God. So this is how the thoughts flow, right? Get the okay, I will increase the font size actually. Get the main value node for the in order successor. Right. Take the root, store it in current, progress to the leftmost, return the current. That's how that is. And then what is the next one? So the insert function was already written and the delete function. So first apply the standard BST deletion. It will take the node and value as the parameters. The base case is if n is equals to null, you will return the null node set and if smaller than root, go left and delete. And if bigger than go right, recursive calling. We are not actually reading it. We are just informing it to go recursively, right? So one or no child. Suppose it learns, so we still get 30 minutes. Okay. I need to take a small break for a minute. Okay, that thing is pumping its wings. Okay, this thing should go up. All right. Uh, hmm. So the else is where we are actually relating to. Okay. So one child or no child case. Child, all right. Root of left is equals to null. Root of right is equals to null. Case for one or no child. Get a ternary operator to see which child is present, left or right. All right. Temp is equals to null. Okay, store it in temp. Store it in temp. So temp is equals to null. Temp is equals to root and free. Root is equals to null. Store root in temp and set root to null. so that it will relate and return. Okay, else means at least one child is present. So then yeah, this code snippet. And you explain what code snippet means. Knowledge term equals to growth and growth is equals to knowledge difference and why are we doing like that? Um, okay, temp now points to the node being deleted. 7. Root is set on null is effectively removes it. Free the memory of the deleted node. Did we write it? Okay. You need to know that. Root label shouldn't copy the contents of a child node. Root open. So instead of removing the root physically and adjusting parent pointers, which is invasive, we just copy the child's data into the current node. Oh, okay. So yeah, I need to understand pointers. So yeah, just the basic delete function. Min value node. Okay, and the right you are getting the min value node, and you are replacing the root of data. I guess I should be writing now. Yeah, no one's there. Looking at the blank compiler, the most painful thing, and also the thing that you learn from the most. Okay, so delete it will take more than, let's say, yeah, first we will write the int in order. Oh, smallest value, smallest value of what? Node. That will take node and node current is equals to n, while current is not equals to null. That means we are getting to the end of this. Current is equals to current of left, and you will return current. Oh, since you are returning current, it should be of node, right? Absolutely. And node delete. What values does this delete function take? Node n and the value to be deleted. We'll take these two values. So the base case is going to be if n is equals to null, means if n is equals to null, we are just returning n because the node is deleted. And now you are writing the classic VST deletion. I mean, where to traverse, right? If value is less than n of data, value is less than n of data. That means the value to be deleted is less than. Then you will move to the left. Delete. Oh wait. Yes, delete is a function. A predefined function actually. Delete node. Is the spelling correct? Yeah. Delete node n of left. Um, it is making sense. Okay, now I understood. I'm not that great in pointers. I'm not that great in recursion. That's why I'm messing here. Value is greater than n of data. That means you are supposed to move to the right. Node of right is equals to delete node of right, and value. We will delete the node that is in the right side. Else, that means if it is not greater, if it is not lesser, that means it is equal, and you have found the node. So now there are two cases. If n of left is equals to null, or n of right is equals to null. So this means either the left child or the right child is null, and now we will get a temporary to see which one is actually present. N of left. This is a grades index. If n of left is present, you are going to return the n of left, or you will return the n of right. Okay. Now, if temp is equals to null, which means if temp is equals to null, or hmm, all right. You will just store and people will continue with this tomorrow. Let's have a great day.